Hello everyone, my name is Mark Petrikowski. I'm one of the lab assistants here at Creighton University. Today I'm going to show you the new design of the new Cyborg Beast Fusion version. So without further ado, we'll get into it, show you some features of it, the functionality of it, and go from there. So the big thing is that this design is now going to be released in the STEP file format, meaning that you guys can import it and play around with it in any software program that you have. Before we were only exporting stuff in STLs, meaning that in Blender was the only capable outcome of the software to be able to use to modify stuff like this. Today, we're releasing it in STP, so you guys have free access to the files and modifying as you wish. A couple of the big features with this is that we're keeping the original tensioner box on there just for ease of purpose, as many people have liked that. The only thing you're going to need is you need the regular screws there. The rest of the model all uses all snap pins, as you can see here. There is no need for Chicago bolts anymore like that, not even to harness anything on the gauntlet or the palm. The gauntlet, you see that there is no slots in here within the file that's being released. There are going to be slots, some heavy dutier ones in there so it won't break as easily. One of the big things with this tensioner is that we're keeping it far back like that. For a better activation of the strings, the fingers being pulled. However, if there is demand for the tensioner to be moved up closer, we more than welcome can do that. We just have to adjust the file. Again, the tensioner is being just one of those, they were just sliding right in there like that. And then the regular pins in there. The snap pins between the palm and the gauntlet, there's a holder on the outside and the pins are nice and flush inside the gauntlet. Pretty straightforward with that. The palm area in here, this part looks pretty thick here. We actually have that part thinned out for the design that we're releasing. That will be all nice and thin in there. The only part that we had to do is keep this side over here a little bit thicker because of the thumb pin that goes there, which we'll explain in a little bit. As you can notice, there's holes right in the finger joints as well too. We'll explain that. That's the normal cable elastic tying, like that. So the palm, all internal cabling, don't have to worry about it getting snagged like that. The only cable that really shows is the outside area here, and then a little bit on this thumb side there. But all internal cabling. With the programs that we're using to print this off, we're using Cura mostly right now. We have used MakerBot. You don't have to worry about any of these channels getting filled up like that. So that's kind of a nice tradition right there. With this slot here, we're going to lengthen those slots there so you actually can weave the cables or weave the Velcro inside here like that for attachments and stuff like that, so you don't have to worry about drilling holes or attaching stuff to the slots on the side like that for Velcro attachment. Everything's going to be woven through the top here, just like how you would do it for the gauntlet, but now in the palm. You're more than welcome to use Chicago bolts if you really want to do that in the gauntlet area. You just have to drill your own holes, and in the palm area the Chicago bolts should fit in the slots right in here like that. You may have to drill them just to make the holes a little bit bigger if you're printing out a smaller size. One thing to note before I go further is that this design is 150%. It is about the same exact size as what 150% Cyborg Beast is as well too. And so without that, we'll go to the elastics, the fingers. As right now, the fingers have a little bit of a give to move up and down. This creates, if you're grabbing a bigger object, let's say like my fist for example, the fingers can grapple around that however we need to, not just so much linear, but so much any kind of contoured shape they need to be. The elastics cabling can be done in multiple ways. You can do it through tying one knot in a finger, routing it through there, and tying the other knot through the other finger. So basically two fingers are linked with one elastic cable. Or you can do the traditional way where you go through the fingers and down through that hole and tie it off there in the bottom. So it's up to preference, whatever you guys like to do for that. Another thing with the fingers is that they are snap pins, so this finger right here has the snap pin on the side, and then the internal snap area in there, so that there's no bolts or anything on the side of the pins like that, or bolts on the side of the fingers, so there's nothing rubbing like that. And then one of the big things is that this one uses an internal snap pin area there that is just one long bolt. The bolt that goes to the knuckle joint and goes to the thumb joint are the exact same size, so you don't have to worry about which one goes where and messing that up and stuff like that. It's all internal here, so you don't have to worry about it coming loose or anything like that. It's nice and tight in there as well too. So you insert one of the knuckle pins in through here, and actually snaps in this back area over here. And then you also do the exact same thing for the thumb area, and it snaps in back over here. The reason why we did the snap pin for the thumb area instead of a Chicago bolt, like traditionally we did, is because back here with the snap pin, you can have this area of the gauntlet nice and clean here, nice and strong, don't have to worry about that snapping anyways. And then onto the thumb, the very last part of this design is the movable thumb. So this has been a big thing that our lab has been doing. I know a lot of people have been asking about this, we just haven't been ready to release it, so now you guys have the chance to get your hands on the thumb. Before we used to have a spring in this gap there, but now with the pin going through like that, the pin's actually a little bit tight onto this movable part. The reason why I did that is so that there's high friction there, so you don't have to worry about a spring and trying to find the right size spring and all that kind of stuff. However, this part does move in and out, so you can activate that any way you want to. You can tell that there's a little bit of a silver looking pin there. What that is actually a part of a paper clip that you guys can just cut off and heat up and insert it into the already pre-printed hole on this movable part in there. So all I have to do is stick it in the hole and then heat it and make sure it's nice and tight in there, and then you should be good to go. Making sure the length is no more than that gap there, so you can move the in and out like that. So the way how the thumb's going to work is that a user would keep their hand locked in there like my left hand is right now, and use their non-affected hand to disengage the thumb by moving it forward. So now you can see that there's a gap back here, and then they have full range to move the thumb in any position they want to, and they get back into position and they slide it back in, and then it's locked in there. What this allows for the user to do is to keep the thumb moving in different positions however they wish to do it. There's already pre-holes in this back area here like that, but you guys are more than welcome to add your own holes for different angles and different degrees you guys want to make the hole at, or make the grabbing motion at. With this right now, the thumb does have a little bit of a wiggle room, which is a good thing because it can create that pinching motion with the pointer finger here, but then it also can create that fist motion where that thumb kind of slides past the pointer finger. So without further ado, we'll show you some functions of it. So right there you can see the pin or the thumb hitting that pointer finger like that, and then it's nice and tight there. But also what you can do is that thumb also slide past it and create that fist motion like that. So with that wiggle room, that thumb can go to the side of it and go down further. That can stop right there, or it can hit that pointer finger right there based on the way how you're going to grip it and the way how they place this thumb area there with that little bit of wiggle room. We would love some feedback and love some comments on this. Any kind of praise or any kind of constructive criticism would be huge. Anything we can do to help fix this or make it better would be perfect. But we're at the point right now where we need your guys' help to give us some feedback, print it off, test it out, see how it all goes. Like I said before, this is the new version of the Cyborg Beast, all designed in Fusion 360. And the files will be released as an STEP file, so please go ahead, please print them off, fool around with it, test it out, give us some feedback, and then we'll go from there and make the changes as needed. So thank you again for watching. Hope to hear from you all soon.